So today we're going to learn about systems of linear equations using matrices. Okay, so the first thing that you need to learn is how to write an augmented matrix of a system of linear equations. Okay, so obviously you're going to have some rows. Okay, in this situation this matrix has m rows. Okay, m is a number. Okay, and then it has n columns. Okay, this is column number 1, 2, 3, 4, 5 up to j, and then n. Okay, so this matrix that you are seeing, okay, you are seeing this is the matrix that you are seeing over here. It's size m times n. Okay, so m is for the number of rows and n is the number of columns that you have. Okay, you're going to tell me, oh, what's up with these values that we have? Well, they are important. Why? Okay, each of these values that you see, a11, a12, a1j, and so forth, we call it an entry. Okay, and each one has a subscript. That's the 1 that you're seeing, the 1 2, the 2 1, and so forth. Okay, the subscript helps you to locate the row and the column of that specific entry. For example, if I tell you find the entry 3, 5, you know that it's going to be the entry in the third row in the fifth column. I will go with that. So a matrix used to represent a system of linear equations, it's what we call an augmented matrix. Okay, so how are we going to deal with that? Well, it's nothing too difficult, or the opposite is quite simple. Okay, so you have your system of linear equations over here. Okay, so the first thing that you need to do with the system of linear equations is you need to make sure that it's in order. By being in order, what do I mean? Okay, so what you want is, I do it alphabetically, is the easiest, and then the equal, and then you're going to have the constant on the other side. Okay, so here you have 3x minus 2y is equal to 3. This one is negative 2x plus y equals negative 2. Okay, so the coefficients of my x are going to be basically in the first column, meaning 3, negative 2. Then this equation, okay, the y's are going to be here, negative 2, 1. I'm going to put this line that it's going to be basically the equivalent of the equal symbol. And then you're going to have the 3 and the negative 2. Are we okay with that? So basically you have all the coefficients of your variables and the constant terms. Are we okay with that? So this is what we call the augmented matrix. Okay, so the only thing that you need to make sure is that it's in order. Now you're going to tell me, well, but in B, kind of concerned because I don't see a Z here. Well, you need to first, before writing your augmented matrix, you need to reorganize this. How are you going to reorganize this one? Well, I'm seeing that I have the X, I have the Y, but I don't have a Z, so leave a space. This plus 5, you need to pass it to the other side as negative 5 here, okay? The second equation that you have over here, you're going to be like, okay, I have the X, okay? So I have the X, I don't have a Y, I do have a Z, okay? And then this guy, I'm going to move it to the other side. Are we okay with that? Now this one is a little bit more user-friendly because you have that it's going to be plus x plus 4y minus 7z equals 0. Okay, so this is your system of equations organized. Now that you have your system of equations organized, I can write pretty simple the augmented matrix. Okay, so you see the coefficients of the x's are going to be 3, negative 2, 1. The coefficients of the y are negative 2, and you're going to tell me what I'm going to put here. Well, since you have nothing, you have 0. Okay, then you have 4, then you have 0, 4, negative 7, the line, negative 5, negative 2, 0, and this is your augmented matrix. Are we okay with that? Now, you might find the backwards process, which is as simple. Okay, so what are we going to do with the backwards process over here? Well, over here you have that you need to write the system of linear equations corresponding to each augmented matrix. Okay, so you know that the first column is going to represent the x's, the second column the y's, and then the other one is going to be the constant terms. Therefore, This is going to be the coefficient of the x, so it's going to be negative 2x plus y equals 3. And this is going to be x plus y equals negative 2. Okay? Are we okay with that? So you have that. It's pretty simple. Don't overcomplicate it. You'll be okay. Okay? Then for this part, what you're going to do is exactly the same. What's the only difference? You know that this is x, this is y, this is z. Okay? And then you have your constants here. Okay? So don't overcomplicate the situation. Just follow the x, y, z, and then the constant. Are we okay with that? So whenever you see this line, you know that it's basically the equivalent of an equal sign. Okay? So the next part is going to be how to perform row operations on a matrix. Row operations, as the name is telling you, it's going to implicate the row. Okay? On an augmented matrix are used to solve the corresponding system of equations. There's 3 super important row operations. Okay, so the first row operation is we can interchange 2 rows. Please make sure that you are aware of something. If we are going to use a matrix, I'm going to interchange the entire row. Okay, it's not entry by entry, it's row by row, the entire row. Okay. Also, the second operation that you have, that it's also pretty simple, you can replace a row by a non-zero multiple of that row, meaning I can multiply row 2 times 2 or row 2 times negative 1, and that's okay as long as every single entry of that row is multiplied times the specific number that I want. Okay, the third operation that we have is we can replace a row by the sum of that row and a constant 0 multiple of some other row. Basically, this is kind of like the combination of number 2 and adding. Okay, so that's what you have. Okay, you know, here it looks a little bit intimidating, but once you see the example, you're going to be like, it's not that bad. Okay, so use words or an example to explain each of the above operations. Okay, so I decided to use examples because I know that it's always better. You can see it, and you know, it's always simpler. Okay, so if I ask you to interchange any 2 rows and I give you this system of equations, the first thing that you're going to do, this is my equation 1 and my equation 2, is you're going to write your augmented matrix. Okay, this augmented matrix, and this example I just created. Okay, it's not I just randomly created. Okay, so you have this is the augmented matrix. If I tell you to interchange any 2 rows, what are you going to do? You are going to interchange this guy by this guy. Okay, so as you can see, the 2 is going here, the 1 is going here, the 7 is going here, and then I interchange all this row and at the top. Are we okay with that? And that's it. Okay, so as you can see, the rows basically they exchange. Okay, that's the first operation. Okay, the second operation, an example of the second operation that we have over here is we need to replace a row by a non-zero multiple of that row. Okay, so if in this case I tell you the instruction multiply row 2 by 2, what are you going to do? Well, first let me explain you a little bit of the notation. Okay, capital R2 is going to be my new row 2. My new row 2 is going to be equal to 2 times my old row 2. Okay, so what are you going to do? Well, this is my matrix. Okay, my, let's say, original for the second part. Okay, so I'm going to multiply row 2, which is this one, by 2. Okay, so 2 times 2 is 4, 2 times 1 is 2, 2 times 7 is 14. So this is going to be my new matrix. Okay, I represent this operation as capital R2 equals 2 lowercase r of 2. Are we okay with that? So that's the example of the second row operation. The third row operation that we have is we want to replace a row by the sum of that row and a constant non-zero multiple of sum. Please note that it's a non-zero multiple of sum. If you multiply a row by a 0, basically you are getting rid of that equation, and that's something that you don't want to do. Okay, remember, an equation is always a piece of the puzzle. So if you multiply that equation times a 0, you are getting rid of that piece. Okay, so you don't want that. Okay, so if I do basically what I'm going to do here is my new row 2 is going to be equal to my old row 1 plus old row 2. Okay, Meaning here, am I talking about row 1, my new row 1? No. So what are you going to assume? You're going to assume that the new row 1 will stay the same. Okay? So the only one that is going to change is row 2. Row 2 is going to be 3 plus 4 is 7. Negative 2 plus 2 is 0. 12 plus 14 is 26. Are we okay with that? So please remember some notation. Lowercase r is my old row. Capital R row, it's my new row. Are we okay with that? So that's what you have. Okay? So in example number 3, we are going to perform row operations on a matrix. Okay, so if we apply this operation that you have over here, meaning your new row 2 is going to be equal to negative 3 old row 1 plus old row 2 to this augmented matrix. Okay, so this is going to be your original. What you're going to do is, well, here is the blah 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 explanation that I just told you. Okay, so what you're going to do is, I'm not telling you to change row 1. So row 1 stays the same. The one that it's changing is row 2. So row 2, you are going to do negative 3 row 1, which is negative 3 times 1, which is negative 3, plus 3 is going to be 0. Then you have negative 3 times negative 2, which is positive 6. Minus 5 is going to be 1. And then you have negative 3 times positive 2, which is negative 6. Plus 9 is going to be 3. And this is going to be your new matrix. Are we okay with that? So that's for row operations. Okay, so in example 4, again, it's more about the same. Okay, it's a little bit more complicated here because it's a bigger matrix. Okay, so the augmented matrix that they are giving you is this one. Okay, so in the instruction they tell you that they want a 0 in row 2 column 1. Okay, so row 2 is here, column 1 is here, so they want that 2 to become a 0. Okay, so you are like, okay, so they are talking about this guy. What are you going to do? How can I make this 2 a 0? Remember, we cannot multiply everything by 0. Okay, so that's the only no. Okay, so what I'm going to do is I decided that my new row 2, okay, because this is in row 2, is going to be equal to negative 2 times my row 1 plus my old row 2. Okay, so my equation is going to be this one. Okay, so I know that negative 2 times 1 plus 2 is 0, so score, that's what I wanted. Negative 2 times 2 is negative 4, plus 5 is going to be 1, and so forth, and I have this equation. Okay, so the only row that changes in this equation is going to be row 2. Okay, the other rows, row number 1 and row number 3, they stay the same. Okay, for part B, it says write your result for part A in the space next to the original matrix and then find the row operation that will result in this new augmented matrix. Okay, so I copied this here. Okay, and then they are telling you the new augmented matrix having a 0 in row 3 column 1. Okay, so they want this negative 3 to be a 0. What are you going to do? Well, basically I'm going to use row 1 as my dummy row. Why? Because I know that if I multiply 3 times 1, I'm going to have a positive 3 and I can get rid of this 3. Okay, so my new equation is going to be row 3 is going to be equal to 3 times old row 1 plus the old row 3, which is this one. Okay, so when you do that, you are going to have this equation. Are we okay with that? So that's another equation with the row operation.